just like, yeah, I'm just gonna. Okay, so we have this. I don't have this point drawn like completely where it's supposed to be. It's really supposed to be the Yankees point. It's supposed to be up here like 52, 500. But anyways, we'll get to that in a minute. Do you think a linear model is appropriate here? What do we think? Looking at this one.
Yes.
Yes, because it's not really strong. It's kind of spread out, probably more moderate, but it is still linear. So although it's not strong, it is linear. So the model is appropriate. Do we have quantitative variables?
Yes.
In scatterplot's linear. Are there any outliers?
The Yankees one.
Yeah. This point, I need to move this point up. This is like very much too low with where it's supposed to be. This point is supposed to be more like up in here. It's supposed to be a little higher so it looks a little more dramatic, but that's fine. And the residual plot, we see nothing of interest here, right? It's just kind of spread all over the place. It's nothing, no direct pattern. So we checked quantitative variables, scatterplot linear, outliers, and residual plot. All right, so interpret the meaning of r squared in this context. So I've got r squared over here is 48.5%. And so y is what is being changed by x. So home attendance is being affected by the number of wins, supposedly. So what we would say is about 48.5% of the variability in home attendance, which is y, can be explained by the regression model with number of wins in the 2006, and that's because it said 2006 season X. All right, so do the residuals show any pattern worth remarking on? So looking at the distance from this line, what do we notice? These points compared to the lines.
They're
Like comparing the two different graphs?
No, like just looking at the left graph. Comparing the points that are on there to the line that's graphed as the line of best fit.
I almost want to
What do
say
you
close, but like not all of them are close. So like.
So where are they not close though?
When it gets higher up.
Oh wait, so would that be?
So when there's more wins, it's farther off, right? From the pattern. So I would say something like, yes, the teams with greatest number of wins deviate from the predicted pattern the most. And sometimes their home attendance is less, even though they have more wins, but that also could potentially be a factor of the size of the stadium. Like, that stadium may still be packed out with, 30,000 people or whatever the number is. That may just be the size of that stadium. So that's why we just say it deviates the most. It's not like necessarily they have more fans because they have more wins or whatever. The point in the upper right of the plots is the New York Yankees. What can you say about the residual for the Yankees? So this one's going to require us to infer a little bit because you can't see that the graph's not perfect, obviously. But residual is actual minus predicted. So up here, the actual amount is 52,500. Okay, I'm telling you that because my graph's not perfect. And the predicted is the line. So the line, I actually did a pretty decent job getting the line on here. Coming across is about at 37,500. If I give you a rough graph, or if there is a graph and it's hard to tell exactly where something is, like, I'm not necessarily looking for you to be perfectly spot on. I'm looking for you to be close and for me to be able to tell why did you pull the numbers you pulled. Usually the ones on the quizzes and tests are going to be a little more clear than this one.
Okay. And the graphs would be given, like, it's not.
Yeah.
Okay.
Yeah. You're already going to have that information. I make sure that on quizzes and tests you already have it. You don't have to, like, write anything in. Unless it's something, like, really small. I may be like, oh, hey, I need to put this up on the board for you or something, but that usually doesn't happen. So what would the residual be then?
15,000.
Yep.
I should not have had
I was really wondering what you were doing, but that's okay.
I was thinking, I don't know.
So what does this tell us about the prediction?
It's great.
It's a positive number, so what do we know about the prediction?
It's
It's-
less than that. Like, wait.
What do you mean?
Like, it's below what it
Yeah.
actually is.
Yeah, the prediction was too low.
Yeah.
Now, if we did it for, one of these other teams down here, we would say what?
It's too high.
The predicted is too high. So obviously, it's, I'm just going to say it's a win-win, but some cases it's a win-win, some cases it's a lose-lose.
Oh wait, so is the line's the prediction and the dots
Yeah.
what actually happened?
Yeah.
Okay.
So the prediction was too low. What is the correlation between wins and average attendance? So correlation is R, but they gave us R squared. So this is going to be R is equal to the square root of R squared, which would be the square root of 0.485. So remember, we got to change it to a decimal. And for the sake of time, I'll just go ahead and tell you that would be 0.696. Now, because it's a square root, okay, obviously when we take the square root of something, we have a plus or minus number. We need to determine if it's plus or minus by looking at the graph. So I need to check the slope of the line. So check slope of regression line to determine if positive or negative. So, looking at the slope of the line from the left graph, what would you say it is?
Positive.
Yeah, so this one is positive. Now, if it's positive, you don't have to write the plus sign. I'm just doing that so that if you go back, you know that we actually did check that. We weren't just making something up randomly. You're going to want to keep this page handy because we're going to need it on the information that you had on this page on the next page. Obviously, I can't have it on the screen at the same time, so I just have mine on my paper over here, but you'll have all of this. I can go ahead and flip. Okay. What would you predict about the average attendance for a team that is 2 standard deviations above the average in the wins? So when we do this one's going to be a little interesting. We haven't had one like this before. 2 times R is equal to 2 times 0.696. Which is going to be 1.393. And you're probably like, what does that number mean? So we wanted something that was 2 standard deviations above in wins. We wanted to know what it means for attendance. So by multiplying 2 times our correlation coefficient, that will give us our standard deviation for average attendance. So that means that we're 1.393 standard deviations above in average attendance.
Does R2 just mean residual? Like R squared?
R squared is the, it's telling us, the variability.
Okay.
So the 0.696,
Was the R value that we got in part E.
does that mean, average wins, or?
That was the correlation coefficient.
Okay. And so we just multiply that by however many.
The standard deviation, yeah.
Okay.
And notice this one was above average, so it's a positive, or we would just continue to say above average. So this next one says, if a team is 1 standard deviation below an average attendance, what would you predict the number of games the team has won? So this one's kind of the reverse. This is about attendance, and then we're going to predict about games won. But when I do 1 times, I don't need to do -1. When I get my final answer, I just need to say below blah blah blah. So this one's going to be the same type deal. 1 times R, or 1 times 0.696, which is 0.696 standard deviations below average, or below average in number of wins. Now, if you need to put -1 to know that it's below so that you remember to go back, but we can't say -0.696 standard deviations below. It's got to be one or the other. The equation for the regression line, so the Y is home attendance, so it's going to be home attendance hat equals, and again, I don't care which order you write it in, so from the little table I gave you on the right hand side, it says that the constant, or the y-intercept, is negative 14,364.5 plus the slope 538.915 times what is x? I don't even remember. Wins.
just so I have it's the the equation, like the general one is like the y hat is equal to b, like is it the 0 or the
I think it's b1 plus b0 times x. I kind of always mix up what they are. I kind of just know what numbers go where.
Sounds good. Oh, I found it.
Just because it's like a weird
Yeah.
way to, do it. So this would be our equation. So now it says to estimate the average attendance for a team with 50 wins. All I do is plug in 50 where wins goes, and then I get the average attendance. So average attendance hat equals negative 14,364.5 plus 538.915 times 50. And this number is going to end up coming out to be 12,581 people in average attendance. And I don't know if this number, I'm assuming more than likely that this is a rounded number because I can't have a half a person. So I would assume that that's rounded to a whole number. And usually especially when it's something like people, we want to round up to the nearest whole person. You can't have like a third of a person. So we would just say if instead of we had 2 1/3 people, we would say we had 3 people usually. But we're also not usually super picky if you round down because, it depends on the context of the question. Interpret the meaning of the slope of the regression line in this context. So that means I'm going up here and I'm looking at this equation and I'm saying, what does the slope mean in the context of this problem specifically? So for each additional win, there's about, and I'm going to round up, 539 additional fans in attendance on average. Now, this next one we kind of talked about a little bit already, but what would a negative residual mean in this context? A negative residual means that the predicted is greater than the actual. So for our specific problem, if a team has a negative residual, the model is an overestimate. Of their average attendance. Meaning there are fewer fans than expected. Y'all both have study hall this period, right?
Mm-hmm.
Okay. I'm going to try to just wrap up this last question so we don't have to finish this one tomorrow. And then there's one more actual example we'll do tomorrow, but this will end this question. So the Cardinals that won the World Series in 2006 are not included in this data because they were an NL team and we were only dealing with American leagues. Okay. So the Cardinals won 83 games and averaged 42,588 fans at their home games. Calculate the residual for this team and explain what that means. So I'm going to just use the equation that they gave me. So attendance hat equals negative 14,364.5. Are you willing to put that over there and it get messed up?
Yeah, I don't care.
Okay.
I'm gonna mess it up.
Oh yeah, that looks horrible.
Plus
So, like,
538.915 times the number of games they won was 83. And again, normally we wouldn't want to do this because they're a National League team and this was data for an American League team. Go ahead. But we're just using this to model for the moment. So this number would give me that they should have had 30,365 fans. Okay, this is the predicted value. The residual, which is actual minus predicted, they actually had 42,588. So 42,588 minus predicted 30,365, which is 12,223 people. So, what does that mean? Is this an overestimate or an underestimate?
that would mean it's
Yep,
which one?
it's an underestimate
Oh,
because
okay,
more
so-
people came than expected. So, model is an underestimate.
Oh wait, so if it's positive, that means it's an under because it's
Yes.
Okay.
Names are restricted.
Yes. So, model is an underestimate for the Cardinals. About 12,223 more people came than expected. And that's it.